Hey everybody, today we're going to do an indoor-outdoor video. We're going to start in here and have a little chat about what we're going to do, and then we're going to go out to Graves Run and we're going to take some water samples. I want to check the pH and the water hardness and so on and so forth. I did this the other day, and what I found in my preliminary testing kind of confuses me, so I want to go out and have another test. If I read my readings correctly, then Graves Run, the stream, the flowing water that flows into the reservoir, has very, very little CO2 in it, like very little, less than 2 parts per million. And the reservoir itself, once the water becomes impounded and is sitting in the reservoir proper, it has a CO2 content over 30 parts per million. And that may be accurate, but it's a little puzzling as to why. Usually rivers and streams have very elevated levels of CO2. To find that Graves Run only has 1 or 2 parts per million seems a bit unusual. The reservoir, of course, might have elevated levels of CO2 in it, but that much also seems a little unusual. It seems odd that it would have between 30 and 40 parts per million CO2 in it. At 40 parts per million, fish wouldn't even be able to live in it. So I'm not really sure what is going on with that. I did shoot a video this morning talking about my pH meter versus litmus paper versus the liquid vial drop test that API uses. I'm not sure if I'm going to post that video. If you want to see it, let me know down in the comments section. I'll go ahead and post it if anybody's interested in watching it. But it was another one of my 8-minute, 9-minute videos of just standing there pointing the camera at some colored vials while I talked about my confusing findings. It never really went anywhere. I never really came to any conclusions, but my findings from one vial to the next and comparing it to my pH meter and all that, I'm not sure which one is accurate. It seems like my pH meter is actually more accurate than the drip test, which seems really odd to me. A chemical reagent should react the same way all the time to the same chemical stimuli. If there's X amount of whatever, then you're going to get this response every time. That's the way a chemical reagent should work. When you've got one of those electronic pH meters, you got sensors and hardware and software and all kinds of stuff in there that might go wrong when you're getting your digital readout. So I would tend to think they're less reliable than the drip tests. But on the other hand, those drip tests rely on you having to discern these tiny, tiny differences in shades of color to determine what, it can be a full point different, and the color is almost impossible to tell, and a 1 point difference in pH, remember, it's logarithmic. So a 1 point difference is 10 times either more acidic or more alkaline, depending on which direction you're going. So when you're looking at one of those vials, and you can't quite tell whether it's, 6.5 or 5.8 or whatever, there's a big difference between those two, and you probably want to be able to dial it in a little more accurately than that. Now, my meter test seems to be fairly accurate with the preliminary testing I've done. I don't have anything that is a known acidity for me to test and verify, and I don't have any distilled water for me to calibrate it at the moment. So what we're going to do is we're going to start by just going out to Graves Run. We're going to take some samples out there. I did a TDS on it the other day. There's only about 95 parts per million dissolved solids in the water. And when I got out to the reservoir proper, the TDS reading was the same, about 95 parts per million. But the pH was a full point to 1.5 difference between the flowing stream and the reservoir itself, and that's where you're going to get your big change in CO2 levels. There's a chart you can use that shows pH versus carbonate hardness, and if you cross-reference them, it'll tell you exactly how much CO2 you have in your water. And when I did that, I got a really high pH and a really low carbonate hardness, which indicates that there's virtually no CO2 in the water. And then likewise, when I tested the reservoir water proper, I got a really low pH, around 6.3, with the same low carbonate hardness, and then that threw the calculation, that threw the reading of the CO2 up over 30 parts per million. So I don't know, but we're going to go out and we're going to do that again today and find out if we get similar readings. So sit tight, let me get in the truck, and I'll see you all out on Graves Run. All right, so here we are at the water's edge. You can see somebody built a little fish trap, it looks like. I guess you get up there and you start working the fish down, and they basically get funneled over and are forced to come right through there. That's actually not a bad way of catching little bait fish and minnows and stuff, and there should be about a bajillion million of them swimming around everywhere. I don't know if you can see them or not, and it's entirely likely that we'll get to see some schools of small fish swimming around back here. So this is where Graves Run flows in, and you can see it's still very much like a stream here. And then as we get down that way, that's where we start getting into where it's basically backed up in pounded water. And about a half mile down this way is where I hiked in my last attempt to make this video, and that's where I shot the video for finding that black mushroom and the video of my boots and all that stuff. It was a weird day, and we never really got any good video of any water testing or anything. So we're going to have a look at the pH, and we're going to have a look at the TDS, see if it's the same as it was the other day, and then we're going to take a sample home. I don't want to use any of the chemical reagent type tests while I'm out here because I'd have nowhere to dump it. So let's see what the TDS meter says. Well, it says just what it said the other day, about 90, 89, 88. It's a little lower than it was the other day. Upper 80s. Oops, sorry. I don't know if you can see that or not. It's getting a lot of glare, but that says 88. Now it dropped down to 73. Of course, I pulled it out of the water for a second. So we're going to say it's the upper 80s. And it was 95 the other day. Of course, it had rained pretty heavily about an hour before I came out here the other day. I was wondering whether that would skew the test or not either. It's kind of drizzly today, but it's not the kind of rain that's got any, cumulative effect. There's no runoff or anything, so we don't have to worry about that. And so now I'm getting a much more reasonable pH. All right, that looks a little better. It was 7.6 when I tested it here the other day. And now it's 6.8, 6.7. Now we're going to call that 6.75, just average it between the two. So those are the two tests I'm going to do here. We will go home, we'll test the carbonate hardness, and that'll tell us how much CO2 is in there. But I can tell you at 6.75 pH, I'm sure the carbonate hardness is going to be about the same as it was the other day, which was 2. And that's going to put our CO2 somewhere probably in the upper 20s, which is where I would expect it to be. So now we're going to go all the way down a couple miles that way across land, and we're going to get out onto the water there. And actually what we're going to find is pretty much identical to what we just saw right here, because I tested it the other day. The pH is probably going to be a little lower. We're going to be around 6.2, 6.3. And the TDS is going to be probably around 90 or something. So sit tight. We'll have a drive back the way we just came, cross over Beckleysville Bridge, and then we will be out on the water out in the main channel. All right, everybody, we're making our way out to that point right there, but I got distracted as I was walking down the trail by a couple things, actually, now that I'm down here. So we're going to have a little detour. Stop and smell the flowers, although these flowers aren't going to have any smell to them, I'm sure. They're really pretty. They look like salvia of some sort, but I don't think they are. The hummingbirds love them. The butterflies love them. I see patches of them out here from time to time. So if anybody knows what these are, let me know. Again, it really looks like a salvia of some sort, but I don't know if it is or not. So the other thing I spotted when I walked down here was, I don't think I'm going to be able to get out too close to it. Can you see that piece of wood right there? That is an awesome looking stump. It's huge, but it looks fantastic. And I've told this story before. In a minute, we're actually going to be right over here, and we're going to see another piece of wood. So actually hang on, and I'll tell you that story in just a minute. Let me get over there. All right, everybody. Well, now I'm a little bit bummed out. We're looking at this piece of wood here, and I actually thought this was the piece of wood that I originally cut up to get the wood that is in my 40 breeder that's also lush and overgrown. I haven't changed it for years. Years ago, I found a really amazing stump, very similar to the one we just saw right over there. I found it out here in the deeper water, and I leaned over in my boat. This is back when I had a John boat, and I lifted it up off the bottom, and I moved it as close to shore as I could get it, and then in the end of the summer when the water levels are going down, I waded out and grabbed it and drug it to shore, and that's where I cut a bunch of pieces of it off, and those are the ones that are still in some of my tanks. I've even got a chunk of it on my little foot tank below my waterfall tank. If you notice that piece of wood sticking up on the far left corner of that tank, that's from that piece of wood that I cut up out here. But I don't see it. It's gone. I actually thought it was this piece here, which isn't a bad piece in its own right. I mean, that doesn't look too bad, but you'd need a really big tank to put a, tree stump that size in it. There's another really good looking piece of wood right here. That's got so much texture and personality. It's amazing. So again, you need a really big tank for something like that. Alright, I guess that piece that I had out here from my other tank is just not here anymore. Or somebody else collected it up and took it home with them or something. I don't know, but it was here for the longest time, years in fact, and now it seems to be gone. Anyway, on with it. We're going to go right on out to this point here, and I will see you there. Alright, and here we are out on the main body of the reservoir. So if you'll look up there, it's kind of hard to discern exactly where we're looking at, but just trust me on this. You can kind of see where the tree line ends right here, and you can sort of see some layers. If you go around that point and go up that way, you are now officially in the cove that is Graves Run. So that's where it flows out into the main body, and of course it's a big, huge expanse of water by the time it gets there. Nothing at all like the stream where we just came from. But we're going to test one end and then we're going to test the other, and of course this is also mixed with water that's coming from up here, which is down the main channel of Graves Run. Gunpowder River. I'm getting all these names confused today. So anyway, here we are at the water's edge. We're going to go ahead and test the pH and the total dissolved solids, and we will see what we get. The other day when I was out here, we had a pH of 6.2 ish, and today it looks like we are actually sitting around 6, just a scooch above 6. I'm gonna call that 6 even. Yeah, if I shake it a little, it drops down. All right, so we're gonna call that a pH of 6, which is even lower than it was the other day. And now dissolved solids, that shouldn't have changed too much. 94, 96, 95, 94, 94. That's pretty much exactly what it was doing the other day. So 90, 95, somewhere in there is where the total dissolved solids is, both at the mouth and out here on the main channel. And the pH, I believe where we just came from, if I'm remembering correctly this time, was 6.6 or 6.7, and it's actually all the way down to 6 now. So even though I got my numbers wrong the other day and got them messed up, that still holds true with what we found the other day. We found that it had a lower pH out here than we did back at the source. So I'm going to scoop up some water. We'll collect that up, take that home with us, back over the bridge that way, and I will see you back at my little work area in the basement. Alright everybody, we have not yet gotten to the carbonate hardness test. We'll do that on camera. I just wanted to do a few preliminary tests on pH and stuff and get a few of these out of the way. Wow, that scared me. I see you. What do you want? Meow. I see you. Are you going to meow at me? You gonna meow at me again? Alright. That was right in my ear. Anyway, if you'll notice, we've got some crazy blue colors in front of us that are not anywhere on this chart. And it makes no sense to me at all. I have no idea what we're looking at here, so bear with me. I actually didn't try the TDS yet, so let's have a look at that real quick. 95, 94. So the TDS is exactly where it was when we tested out on the water. That was my main channel water. My pH, when I tested here, got the same thing I got out at Graves Run, or more or less. It came out at 6.4. When I tested my main channel water, I got the same thing we got out on the water, which was about 6.1, at least close enough. You know, sitting in a little glass like this or in a bag, it's been sitting there for a few minutes. The pH isn't necessarily going to be exactly the same, but we will talk about that in a minute too. So this is the water from, I know it's kind of weird the way I've got these set up, but this is the first test I did, and that is from the main channel, I mean the Graves Run, the stream. And when I got that blue, you know, that registers up here at 7.6, showing that it's pretty much off the scale for the low end. So I used some of the high end test solution, and it falls below the high end. I know that looks kind of orange, like that 7.8, but that's not. That's like a beige color. So it falls in between again. It falls in one of those weird, you can see how it jumps from, you know, it goes in increments of 0.2, and then we jump all the way up to 7.6. That's where you sort of go off the scale above 7.2. This scale starts at 7.4 and then goes in increments. So we're somewhere past the 7.2, but not yet at the 7.4 or something, I guess. I don't know. I don't know why I get that weird kind of in-between result. But my meter shows that we are sitting around 6.4, and I did not do a litmus paper test on that. Or yeah, I did on this. I did not do a litmus paper test on that. The litmus paper test on that showed somewhere, you know, it wasn't quite as orange as 6, but it wasn't quite green like 7 yet. It sort of fell somewhere in between 6 and 7, which to my eye would put it around 6.4, which again is what my meter showed me. Why am I getting that when I use the API test kit? I have no idea. The even more baffling part is this. And the reason there's 2 tests there was I didn't believe my eyes when I did the first test. I thought I did something wrong. So I got a second vial, rinsed it, cleaned it out. I made sure there was nothing contaminating it, and we used water from the main channel. I rinsed it out with water from the main channel. I rinsed the cap out with water from the main channel, so nothing was contaminating it. And I did a second test, and I don't know, you tell me what that means. That's the low-end test solution. And this is water from the main channel that my TDS meter shows at 95 parts per million. So even if that was all calcium, it just simply can't be that hard. And it can't have that high of a pH. I don't think it can have that high of a pH. So I'm not so sure I even trust these little API drops anymore. I don't know why I'm seeing these weird numbers, but next we're going to have a real quick look. Since we're standing here, we're going to look at a piece of litmus paper and see what that shows us. So this is from the main channel again, and should stay fairly close to that orange of the 6. You know, a little bit of greenish color showing up in there. So you tell me which one that looks more like. Well, we can't really tell now that we've set it on the thing. But there's 6. And there's 7. With it lying on the table, it looks closer to 7. So I don't know. That's why I always hate these things. That's why I always get confused when it comes to the pH. I pull it off of there, and now it looks orange again, and it looks more like 6 than 7. But the water it left behind looks dark green. So I don't know. Maybe if I took a science class and they told me exactly how I'm supposed to read litmus paper properly, I'd have a better understanding. And this is exactly why I hate color changing tests. I want a test that tell me what my pH is. Don't give me these guess the color chart. Anyway, that's where we stand as of now. Next we're going to do carbonate hardness, and I'm going to ignore this. We're going to go by the pH of what that says, and we're going to check the carbonate hardness, and that'll give us an idea of how much CO2 we've got in there. Alright, now we're not going to test the general hardness today. I've tried that before, and I always come up with nothing, so I'm sure the water around here is as soft as mine, which is 0 degrees hardness. Now this is carbonate hardness. We're going to put our first drop in. That should give us a color change. Turns a bluish sort of color. Let me flip that over. Now this drop should change the color. This will be the second drop, and this will make it 2 degrees carbonate hardness. And we should get a shift to like a yellow color if I'm not mistaken. There we go. So that is George's Creek water. This is the main channel water. First drop should turn it blue. And this will be the second drop. It should turn it yellow, which will give us 2 degrees carbonate hardness. Now, as I've said before, it's not just supposed to do it on the second drop. That just means it's 2 degrees carbonate hardness. If it was 5 degrees carbonate hardness, then it would have taken 5 drops for that color change to happen. The first drop changes the water to blue, and then you count 2, 3, 4, whichever drop is the drop that changes the color. That's how many degrees carbonate hardness you have. So we have 2 degrees carbonate hardness in both the stream and the main channel, and we're going to use those pH numbers we came up with. I'm going to do a few calculations, and then I will see you back in front of the tank, and we can talk about what we just found out. Alright, so I went upstairs and looked at the chart, and I'm getting some questionable numbers again, and all is going to fall down to whether or not that pH is accurate. So I really am going to have to calibrate that pH meter and see what's going on with that. But according to what I found out, if the pH in the stream was 6.7, then we would have had a CO2 value of about 12 parts per million, which is kind of low for a stream. If the CO2, if the pH was 6.5, then the pH or the CO2 level would have been about 23 parts per million, which is getting closer to about what you'd expect it to be, at least above 20. So again, the stream, we're in the neighborhood. You know, the streams seem to be about right. If the pH was about 6.6, 6.7, that'll put us around 12 or 15 parts per million, something like that. It's when I get out into the main channel that it gets a little confusing. If we go by what the pH was when we were out on the water, if I remember correctly, the reading was fluctuating right around 6. And if it was 6 with a carbonate hardness of 2, then that means we've got 60 parts per million CO2 in the water, and fish certainly could not survive levels that high. So something's not right there. If we go all the way up to 6.3, that puts us right at 30.1 parts per million if we go up to a 6.3 pH, and that's right at the tolerable level where fish can survive. Anything above 30 parts per million and you're really running the risk of fish dying. So 30.1 is borderline, and that would be a 6.3 pH. If we go up to a 6.4 pH, then that brings it down to 23.9 parts per million, which again is about where I would expect it. So I think that the water out there with the wind blowing and the waves rippling, I know if you just shake the pH meter around in the water, the number goes all over the place. So I was probably getting a little bit of a funny reading from that. When I brought it home and I was checking the water in the bag where it was still, I was getting a reading of 6.4. And again, that would put us right around 24 parts per million CO2, which is about what I would expect in a big standing body of water like that. So I will check my pH meter next time I'm at the store. I only really go to the store when I need to, and I'm not going to run up there just to get some distilled water because I'm curious about some pH. So next time I get a chance to get some distilled water, I will go ahead and calibrate my pH meter, and we can maybe do an update on this video and see if we got any different results or anything. But I think we're pretty accurate. I think we're right in the neighborhood. I think we're looking at a pH around 6.4, 6.5, somewhere in that neighborhood, which is again what I expected it to be. The water around here is just soft and acidic. I don't know why it would be any different out in Prettyboy Reservoir. So all in all, I think that the water there is really, really similar to the water I've got in my tanks. The only real difference we're going to see, as I said before, is a much, major reduction in sunlight and a major reduction in CO2 levels, because my tanks probably have at the most 5 or 6 parts per million CO2, and if, you know, that's probably even high. It probably has more like 4 or 5 parts per million CO2. I don't think that's going to have an effect on my plants. I think they'll adjust just fine. The lower CO2 levels are going to correlate with the lower light levels, and you know, it's not going to matter. They only can use that extra CO2 if they've got tons of light generate. You know, they got to have that engine going to keep that fuel burning, and if you just don't have all that sunlight, you just don't have a need for all that CO2. So my lower lighting situation with the lower CO2 levels, again, I just don't think, other than any initial shock from going into my tanks from where they were, you know, I don't think we're going to have any problems with that. So no real super point to that. It was just kind of fun to go out and check it out. Again, this is just my curiosity, my day-to-day tinkerings with my hobby. As I've said before, you know, this isn't any kind of professional operation here. These are just my fish tanks and my hobby, and stuff like that piques my curiosity, so I go out and check it out, and now I know. And you do too. So thanks for watching. Hope you enjoyed. We will be talking more about this in the future as I get my pH meters squared away. Again, I'd really be interested to hear anybody else's opinion about pH meters, pH tests, whether you've had these same problems, whether those colors confuse you, or you have trouble discerning one color from the next or whatever. Anyway, you know how it works. Go down below, leave a comment. I'll be glad to get back to you if I can. Thanks for watching. Make sure you're subscribed, and I will see you real soon in the next one. Oh, don't forget to check me out on Facebook. I got a new Facebook fan page over there. I keep forgetting to promote, but it's similar to my YouTube channel. I post all my YouTube videos over there, but I do a few little odds and ends and other stuff, short videos, pictures, whatever winds up getting posted over there. So check out my fan page over on Facebook. There will be a link down below to that as well. And again, I will see you real soon in the next one. Thanks for watching.